Hi there. So in this video, we'll be looking at probability trees. So first off, let's imagine there's a teacher with some books and she's walking carrying those books in the direction of a banana and there's a 50% chance she'll trip over the banana, so 1 in 2, and that's possibility 2. And possibility 1 is she doesn't trip over the banana, manages to walk around it. So what a probability tree does is it shows all possibilities as branches, like branches of a tree. So we have a starting point here for the probability tree, a small dot. Then we have all possibilities from there branching out. So there's a 1 in 2 chance here we can see on the branch below where you don't trip over the banana. Then a 1 in 2 chance that the teacher does trip over the banana. So this is quite a simple case with two possibilities. But when more possibilities come up, that's when probability trees end up being extremely useful. So here's a more complicated example where let's forget about the banana for now and imagine that a ball is thrown in front of the teacher. And with this ball, let's for the ball assume that there's a 50% chance, a 1 in 2 chance she trips over the ball, and a 1 in 2 chance she doesn't. But now let's assume that if she does stumble over the ball, this will change the probability of whether or not she trips over the banana. Because if she trips and stumbles over the ball once, she'll probably be quite a bit more careful walking and then be less likely to trip over the banana. So let's assume that if she stumbles over the ball, there's a 3 in 4 chance she does not trip over the banana, and a 1 in 4 chance she does trip over the banana. So I'm just going to show these probabilities here a sec. So there's the 3 in 4 chance of not tripping over the banana, and the 1 in 4 chance of tripping over the banana. And of course, if she doesn't trip over the ball, then like before, there's a 50-50 chance she does trip over the banana. So if she doesn't trip over the ball, she could either trip over the banana, 50% chance, 1 in 2 chance, or 1 in 2 chance she doesn't trip over the banana. And now we've got our probability tree with all the combinations of possibilities shown. We can we can now work out various things. For instance, let's say we wanted to work out the probability that she trips over the ball and trips over the banana. And when you hear the word and in probability, that's when you should think multiply. So the probability she trips over the ball is 1 in 2, but then once she trips over the ball, there's only a 1 in 4 chance of tripping over the banana because she'd be more careful after tripping over something once. So because you trip over the ball and the banana, you as you're going up branches on the tree, hence the and, you multiply the probabilities together. So 1 in 2 times 1 in 4 is a 1 in 8 chance that the teacher trips over both the ball and the banana. And now let's work out the probability the teacher trips over either the ball or the banana. And there's quite a bit of calculation for this one, so I'll just explain with some of the color coding. So first we had the probability of tripping over the ball and the banana, which is 1 in 2 times 1 in 4, which is 1 in 8. But then we also have, going up a different combination of branches of the trees, there's a 1 in 2 chance of the tripping over the ball and not tripping over the banana. So for this, going up the tree, we have the 1 in 2 chance multiplied by the 3 in 4 chance to get to no banana. And then there's another possibility for tripping over either the ball or the banana, which is she doesn't trip over the ball, but then she does trip over the banana anyway. And so to get to banana 3, we have 1 in 2 times 1 in 2, which is 1 in 4. And if we add up all these possible combinations, so the combination of the ball and the banana, the ball and not the banana, or no bone banana, we get 1 in 2 times 1 in 4, plus 1 in 2 times 3 in 4, plus 1 in 2 times 1 in 2. And this gives us a total of 3 in 4. And notice that they're all highlighted in this greeny blue color because when you see or in probability, this usually means adding, because unlike with and, when you're going up the branches, so you multiply the probability of each one, with or, you're summing up different combinations of possibilities. And so for tripping over at least one of the ball or the banana. We total all these up to get 3 and 4, and I'll just show these possibilities with a blue tick here. So this is all the combinations which you add up when you look at the probability the teacher trips over either the ball or the banana. But now let's look at the probability the teacher trips over neither. So this will just be the no ball, then no banana. So 1 and 2 times 1 and 2, which is equal to 1 and 4. And this is shown by a cross that shows neither of the options of tripping over one of them. But now we've got all the possibilities either ticked or crossed, depending on whether or not the teacher trips over one of them. So we've got the 3 and 4 for the ticks and 1 and 4 for the cross. But notice if you add the 3 and 4 and 1 and 4, you end up getting 1. And this is what you should get actually, because it shows that all combinations of possibilities on the probability tree have been covered. So all these probabilities should end up adding to 1. So thanks for watching.